This video is about the tangent function. This is AP Precalculus Topic 3.8. If you appreciate this content, please give it a like. Number 1. A portion of the graph of the function f is shown in the xy plane, where f is the result of a multiplicative transformation of the graph of the parent function y equals tangent x. What is the period of f? The period of a tangent function will be the horizontal distance between consecutive asymptotes. 3 pi minus pi is 2 pi, so the period is 2 pi. The period is also the horizontal distance between consecutive midline intercepts. So, from 0 to 2 pi, again, the period is 2 pi. Number 2. The function h is given by h of x is equal to 7 minus 3 times the tangent of 4x. What is the period of h? The period of a tangent function is given by pi divided by the b value. So in this case, the period will be pi divided by 4 because that's the b value. And that's it. The period is pi over 4. Number 3. The function g is given by g of theta equals the tangent of theta divided by 3. What is the period of g? Let's do a small rewrite. Theta divided by 3 is the same as 1/3 times theta. So this way we can easily see that the b value is 1/3. Now we know that the period is always pi divided by the b value for a tangent function. So the period will be pi divided by 1/3. However, when you divide by a fraction, you multiply by the reciprocal. So the period will equal pi times 3. Therefore, the period is 3 pi. Number 4. The function k is given by k of theta is equal to the tangent of pi theta. What is the period of k? Well, the period of a tangent function is given by pi divided by the b value. In this case, the b value is pi. So the period is pi over pi, which equals 1. Number 5. The function p is given by p of theta is equal to the tangent of pi theta over 4. What is the period of p? Pi times theta over 4 is the same thing as pi over 4 times theta. But written this way, it's easier to see that the b value is pi over 4. The period for a tangent function is given by pi divided by the b value. So pi divided by pi over 4. When you divide by a fraction, you multiply by the reciprocal. So the period will equal pi times 4 over pi. The pi's cancel each other out because we have one high and one low. That leaves the period is equal to 4. Number 6. The function j is given by j of theta is equal to the tangent of 2 theta. Which of the following gives the vertical asymptotes to the graph of j? I'm going to put this part in a thought bubble because this is not something you need to write down. But the tangent of 2 theta is equal to the sine of 2 theta divided by the cosine of 2 theta. The vertical asymptotes will occur where tangent theta is undefined. That will be where the denominator is equal to 0. In other words, that will be where the cosine of 2 theta is equal to 0. We start by solving for 2 theta by asking ourselves the cosine of what is equal to 0. On the unit circle, cosine is the x value, and the x values will equal 0 here and here. So here at the top, this is pi over 2. So this is the first solution. 2 theta is equal to pi over 2. However, we need the infinitely many solutions, so I'm not just going to start making a list like pi over 2 and 3 pi over 2. Instead, I'm going to recognize that from the first solution to the next solution is a semicircle. It's pi radians. So, in fact, if I go another semicircle, it takes me back to another solution. So every time I go pi radians, I'm going to get another solution. So I can get the infinitely many solutions by adding multiples of pi. In other words, pi k, where k is any integer. So we just need to get theta by itself by dividing both sides of this equation by 2. So we will have theta equals pi over 2 divided by 2 is pi over 4. And pi k divided by 2 is just pi over 2k. So the answer is C. Number 7. The function f is given by f of theta equals the tangent of 1/4 theta. Which of the following gives the vertical asymptote to the graph of f? Again, you should be thinking to yourself that the tangent of 1/4 theta is equal to the sine of 1/4 theta over the cosine of 1/4 theta. The vertical asymptotes will occur where tangent is undefined. That's where cosine, the denominator, is equal to 0. To solve this equation, we first solve for 1/4 theta by asking ourselves the cosine of what is equal to 0. On the unit circle, cosine is the x value, and x values are equal to 0 here and here. So 1/4 theta will equal pi over 2, that's what's at the top, or 3 pi over 2. But since we need the infinitely many solutions, I'm not going to put 3 pi over 2. I'm just going to recognize that the distance from one solution to the next is pi radians. So to get all of the solutions, I will add multiples of pi. I will add pi k. To get theta by itself, I need to multiply both sides of this equation by 4. Multiplying by 4 on the left, we have theta. Multiplying pi over 2 by 4 gives us, for a moment, 4 pi over 2. And then multiplying this by 4, we have 4 pi k. Of course, 4 over 2 simplifies to 2 pi, so I think I'll just fix it. So this term quickly becomes 2 pi. So the answer is C. Number 8. The function g is given by g of theta equals the tangent of pi theta. Which of the following gives the vertical asymptotes to the graph of g? You should be thinking the tangent of pi theta is equal to the sine of pi theta divided by the cosine of pi theta. The vertical asymptotes will occur where the tangent of pi theta is undefined. That's where the cosine of pi theta, the denominator, is equal to 0. So we need to solve this equation. Cosine of pi theta is equal to 0. First, we solve for pi theta by asking ourselves the cosine of what is equal to 0. Cosine is the x value on the unit circle, and x values are equal to 0 here and here. At the top, we have pi over 2. To get the infinitely many solutions, we recognize that the distance in radians from one solution to the next is always going to be pi. So we just need to add multiples of pi. So we add pi k, where k is any integer. To get theta by itself, we need to divide both sides by pi. So we get theta is equal to. So dividing by pi, look, for a second we would have pi over 2 pi. Okay, dividing pi over 2 by pi will put an extra pi in the denominator. However, these pi's are just going to cancel each other out, leaving behind a 1/2. Pi over 2 divided by pi cancels out the pi, and you get 1/2. Of course, pi k divided by pi cancels out this pi, and you are left with k. So the answer is C. One more time. Number 9, the function h is given by h of theta equals the tangent of theta minus pi over 2. Which of the following gives the vertical asymptotes to the graph of h? You should be thinking the tangent of theta minus pi over 2 is equal to the sine of theta minus pi over 2 divided by the cosine of theta minus pi over 2. The vertical asymptotes will occur where the tangent of theta minus pi over 2 is undefined. That's where the denominator cosine of theta minus pi over 2 is equal to 0. We begin by solving for theta minus pi over 2 by asking ourselves the cosine of what is equal to 0. Cosine is the x value on the unit circle, and x values are equal to 0 here and here. Here at the top we have the solution of pi over 2. And instead of putting 3 pi over 2, we get the infinitely many solutions by recognizing that the distance between one solution and the next solution will always be pi. So adding multiples of pi will always give us another solution. So that's pi k, where k is any integer. We can get theta by itself by adding pi over 2 to both sides. So we have theta equals. But if you add pi over 2, let me just show this for a second. We're adding pi over 2 to both sides. These are like terms. Pi over 2 plus pi over 2 is 2 pi over 2, or simply pi. So when you add pi over 2 and another pi over 2, you get pi. So this becomes pi plus pi k. Now I'm going to try to convince you that pi plus pi k and simply pi k represent the same set of numbers. Remember that k is any integer, so k represents numbers like -2, -1, 0, 1, 2, and so on forever in both directions. Pi k would be all of these numbers multiplied by pi. So this would be -2 pi, -1 pi, 0 pi, which is just 0, 1 pi, which is pi, 2 pi, and so on forever in both directions. Pi k plus pi will be all of these same numbers plus an extra pi. So if I add pi to this, I'm going to get -1 pi. If I add pi to this, I'm going to get 0. If I add pi to this, I'm going to get pi. If I add pi here, I'm going to get 2 pi. If I add pi to this, I'm going to get 3 pi. But all of these lists go in both directions forever. So I sort of arbitrarily stopped the red list at -2 pi and +2 pi, but I could have kept going, and then the next number would have been 3 pi. Okay, and this purple list, I have it listed from -pi to 3 pi, but if I added one more number on to the left, I would have -2 pi. And these numbers keep going. So hopefully now you can see that pi k and pi k plus pi really represents the exact same set. In other words, pi plus pi k simplifies down to simply pi k. So the answer is C. Number 10. The graph of the function f is given in the xy plane if f of x is equal to a times the tangent of bx, where a and b are constants. Which of the following is true? This is the graph of the parent function y equals tangent theta. I want you to notice and memorize that the parent function is always increasing from left to right. As we go from asymptote to asymptote, one period of tangent is a continuously increasing function. So if we see a transformation that is decreasing, that is going to be a reflection over the x-axis, which means we would have a negative a value. And that's what we see here. Because these waves are decreasing, we know that this tangent function is a reflection over the x-axis, and the a value must be negative. So we can eliminate option A and option B. We've narrowed it down to C or D. So what about the B value? We have learned that the B value is given by pi divided by the period for a tangent function. The period can be measured from intercept to intercept on the midline. From 0 to pi over 2, that's a period of pi over 2. So the B value is pi divided by pi over 2. When you divide by a fraction, you multiply by the reciprocal. So B is going to equal pi times 2 over pi. The pi's cancel out because we have one high and one low. So B is equal to 2. Well, that means that B is greater than 1. So the answer is C. Number 11. The graph of the function g is given in the xy plane if g of x is equal to a times the tangent of bx, where a and b are constants. Which of the following is true? Well, this time we see that we are presented with an increasing function. That means that this tangent function is not reflected over the x-axis. It is sort of right side up. So we know that the a value is positive. So we have narrowed it down to either A or B. We can forget about C or D. What is the period? The period can be measured from midline intercept to midline intercept. From 0 to 2 pi, that tells us that the period is 2 pi. We can use this to figure out the B value, which is always given by pi divided by the period for a tangent function. So that's going to be pi divided by 2 pi. The pi's cancel out, leaving a B value of 1/2. And 1/2 is less, well, let me look over here. The 1/2 is less than 1. So that's why the answer is B. Number 12. The graph of the function h is given in the xy plane if h of x is equal to the tangent of b times x plus c, where b and c are constants. What are the values of b and c? We need to start by finding the period, because the period will lead us to the b value. You can measure the period either from midpoint intercept to midpoint intercept, or from asymptote to asymptote, whichever is easier. In this case, it will be easiest to measure the period from vertical asymptote to vertical asymptote. That is from 0 to 2 pi, so the period is 2 pi. If you went from midpoint intercept to midpoint intercept, you can probably see that from negative pi to positive pi is also 2 pi. Now we can find the b value. The b value is always given by pi divided by the period, so pi over 2 pi. The pi's cancel each other out, leaving b equals 1/2. Okay, so we can eliminate options C and D. The C value is the opposite of the phase shift. When looking for the phase shift of a tangent function, you should view one period of the tangent function as going from midpoint intercept to midpoint intercept. So one period of this tangent function is going to appear sort of like this. So for the phase shift, we would think of negative pi or potentially positive pi. But let's start with this one because this is the beginning of the only full period that we see that goes from midpoint intercept to midpoint intercept. So if this is the phase shift, then that would correspond to a C value of positive pi. Let's see if that is one of the answers. It is not one of the answers. So let's go to the other midpoint intercept. If this is thought of as the phase shift, then the C value would be the opposite of pi, negative pi. That is one of the answers. So that tells us that the answer is B. Number 13. The graph of the function k is given in the xy plane. Which of the following could be an expression for k of x? I'm noticing that all of these functions have different b values. So we should be able to calculate the b value that goes with this graph and then see which one of these functions is a match. However, I can't help but noticing that a is not the answer because a has a negative a value, which would make it a decreasing function from left to right. This is an increasing function, so the answer is not A. Now, let's find that B value. We begin by finding the period. You can measure the period either from asymptote to asymptote or from midpoint intercept to midpoint intercept, whichever is easier. In this case, we are going from 0 to pi over 2 if we do intercept to intercept. So the period is pi over 2. The b value is given by pi divided by the period for the tangent function. So that's pi divided by pi over 2. When you divide by a fraction, you multiply by the reciprocal. So b is equal to pi times 2 over pi. The pi's cancel out because we have one high and one low, leaving a b value of 2. Aha! Option C is the only one that has a b value of 2. So that's the answer. Number 14. In the xy plane, an angle theta is in standard position. The slope of the terminal ray of the angle is -1. Which of the following could be the measure of angle theta? Let's consider each answer one at a time. Pi over 4 would have a terminal side ending right here. Notice that the terminal side has a positive slope. Positive one, not -1. So A is not the answer. The terminal side of pi over 2 is vertical. The slope would be undefined. So the answer is not B. In what quadrant is 3 pi over 4? We know that pi is right here. So we can think of pi as 4 pi over 4. Therefore, 3 pi over 4 is pi over 4 less than this. 3 pi over 4 ends right in the middle of the second quadrant. Notice that the slope of the terminal side is -1. So the answer is C. Number 15. In the xy plane, an angle theta is in standard position. The slope of the terminal ray of angle theta is undefined. Which of the following could be the measure of angle theta? Since the slope of the terminal ray is undefined, we are looking for the angle that has a vertical terminal side. And 3 pi over 2 has a terminal side that lands right on the y-axis. Because the terminal ray is vertical, the slope will be undefined. So the answer is C. Number 16. In the xy plane, an angle theta is in standard position. The slope of the terminal ray of angle theta is radical 3. Which of the following could be the measure of angle theta? If you have not yet memorized these 9 trig facts, pause the video and study the chart right now. We have learned that the tangent of theta is the slope of the terminal side of theta. When they say the slope of the terminal ray of angle theta is radical 3, that's a long way of saying the tangent of theta must equal radical 3. Notice that the tangent of pi over 3 is radical 3. So if I saw that pi over 3 was one of the answers, then that would be the answer. As it is, this pi over 3 tells us that the reference angle must be pi over 3. Between 0 and 2 pi, there are 4 angles that have a reference angle of pi over 3. There's one in every quadrant. When we say the reference angle is pi over 3, we're talking about the space between the x-axis and the terminal side. So we are saying that this angle right here is pi over 3, and this angle right here is pi over 3. Similarly, these blue angles are also pi over 3. So that's what I mean when I say reference angle of pi over 3. Remember that tangent is the slope of the terminal side of the angle. In this case, the tangent is positive radical 3. That means we are looking for an angle with a positive slope. So look for the terminal sides that are going uphill. So this is a negative slope in the second quadrant and in the third quadrant. So the answer is going to be one of these two answers. And we already saw that in the first quadrant, it's simply pi over 3, and that is not one of the answers. What do we call the angle that starts at 0 and then goes all the way around to here? Well, remember, pi is right here, and we can think of pi as 3 pi over 3. So this angle is pi over 3 more than 3 pi over 3. That makes this angle 4 pi over 3. That's why the answer is C. Number 17. In the xy plane, an angle theta is in standard position. The slope of the terminal ray of angle theta is 0. Which of the following could be the measure of angle theta? A slope of 0 is a horizontal line. At pi over 2, the slope is undefined. At 3 pi over 4, the slope is negative 1. At pi, the slope is 0 because we have a horizontal line. So the answer is going to be C because it says pi. However, just to finish it out, 3 pi over 2, the slope is undefined. So pi is the angle where the slope is 0, and the answer is C. Number 18. In the xy plane, an angle theta is in standard position with measure theta equals pi over 6. Which of the following is true? All of the answer choices describe the slope of the terminal ray, and we know that the slope of the terminal ray is given by tangent theta. If theta is pi over 6, then the slope of the terminal ray will be the tangent of pi over 6. Make sure you memorize this chart, which includes the tangent of pi over 6, which is 1 over radical 3, or radical 3 over 3. That's why the answer is B. Number 19. In the xy plane, an angle theta is in standard position with measure theta equals 5 pi over 4. Which of the following is true? Well, again, all of the answer choices describe the slope of the terminal ray. And again, the slope of the terminal ray is given by tangent theta. If theta is equal to 5 pi over 4, then we are simply looking for the tangent of 5 pi over 4. In what quadrant is 5 pi over 4? Pi is right here, and we can think of pi as 4 pi over 4. Therefore, 5 pi over 4 is 1 pi over 4 more than 4 pi over 4. So 5 pi over 4 will be right here in the third quadrant. The angle between the x-axis and the terminal side is called the reference angle. And since 5 pi over 4 is 1 pi over 4 more than 4 pi over 4, the reference angle is pi over 4. We have memorized all the facts on this chart, including the fact that the tangent of pi over 4 is 1. The tangent of 5 pi over 4 will be the same as the tangent of the reference angle, which was 1, except that it might be positive or it might be negative depending on the quadrant. We are in quadrant 3, and we remember that tangent is the slope of the terminal side. And this slope is positive. See how it goes uphill in this quadrant. So therefore the tangent will be positive, positive 1. So the answer is D. Find the exact values for the following expressions if possible. I'm going to be drawing a lot of little pictures for instructional purposes, but I encourage you to do all of this in your head if you can. For number 20, in what quadrant is 7 pi over 6? We can think of pi as 6 pi over 6. Therefore, 7 pi over 6 is pi over 6 more than 6 pi over 6, placing it in the third quadrant. So this tells me two things. In the third quadrant, the slope is positive. So the tangent is definitely going to be positive something. To get the actual answer, I also need to be aware of the reference angle. Remember I said 7 pi over 6 is 1 pi over 6 more than 6 pi over 6? That tells me that the reference angle is pi over 6. Now we use our memorized facts. Since the tangent of pi over 6 is 1 over radical 3, the tangent of 7 pi over 6 will also be positive 1 over radical 3. Or you could put radical 3 over 3. Number 21, in what quadrant is 3 pi over 4? Well, we can think of pi as 4 pi over 4. 4 pi over 4. Therefore, 3 pi over 4 will be pi over 4 less than 4 pi over 4, placing it here in the second quadrant. We also see that the reference angle is pi over 4. In the second quadrant, the terminal side has a negative slope, so we know that the tangent will be negative. Now consider the reference angle. Since the tangent of pi over 4 is 1, the tangent of 3 pi over 4 will be negative 1. Number 22, in what quadrant is 2 pi over 3? Well, we can think of pi as 3 pi over 3. Therefore, 2 pi over 3 will be pi over 3 less than 3 pi over 3, placing it right here in the second quadrant. In the second quadrant, the slope of the terminal side is negative, so the tangent will be negative something. We can see that the reference angle is pi over 3. Since the tangent of pi over 3 is radical 3, the tangent of 2 pi over 3 will be negative radical 3. Number 23. In what quadrant is 5 pi over 3? We can think of pi as 3 pi over 3, and then what we normally call 2 pi can be thought of as 6 pi over 3. I'm doubling this. So therefore 5 pi over 3 will be pi over 3 less than this, placing it here in the fourth quadrant. In the fourth quadrant, the terminal side has a negative slope. See how it's downhill? That tells us that the tangent will be negative something. This angle between the terminal side and the x-axis is pi over 3. So that is the reference angle. And since the tangent of pi over 3 is radical 3, the answer will be negative radical 3. Number 24. In what quadrant is 11 pi over 6? First of all, there's my initial side. We can think of pi as 6 pi over 6, and we can think of 2 pi as 12 pi over 6. Therefore, 11 pi over 6 will be pi over 6 less than 12 pi over 6. So that's going to be right here in the fourth quadrant, where the slope of the terminal side is negative. So we know the answer will be negative something. Furthermore, the reference angle is this tiny little pi over 6 right here. So the reference angle is pi over 6. And since the tangent of pi over 6 is 1 over radical 3, the answer will be negative 1 over radical 3. Or you could say negative radical 3 over 3. For number 25, 2 pi does not fall in a quadrant. 2 pi we know to be all the way around and then back to where we started from. So 2 pi lands right here. So we will not use our chart of memorized facts for this one. We will just use the slope. See how the slope is 0? Because it is a horizontal line. So we will just immediately say 0. In number 26, a negative angle means that we rotate in the clockwise direction instead of the usual counterclockwise direction. Negative pi over 2 is going to land right here, where the slope of the terminal side is undefined. A vertical line has an undefined slope, so that's why the tangent is undefined. 27. In what quadrant is 5 pi over 4? We can think of pi as 4 pi over 4. Therefore, 5 pi over 4 will be pi over 4 more than this. This tells us that we are in the third quadrant where the slope is positive, thus the tangent is going to be some positive number. It also tells us that the reference angle, this little angle right here, is pi over 4. So the tangent of 5 pi over 4 will be the same as the tangent of the reference angle, and the tangent of pi over 4 is 1. Number 28. In what quadrant is 7 pi over 3? We know that pi can be thought of as 3 pi over 3. If you double that, you get 6 pi over 3. So what we normally think of as 2 pi is the same as 6 pi over 3. So far we've gone all the way around and back to the starting position. However, 7 pi over 3 will be pi over 3 more than this. So that is going to put me into the first quadrant again. Okay, so it's like going an extra pi over 3 to here. The fact that I just went an extra pi over 3 tells me that the reference angle is pi over 3. That tells me that the answer will be the tangent of this reference angle, and the tangent of pi over 3 is radical 3, except for I need to be careful to consider whether it is positive or it could be sometimes negative. However, in the first quadrant, the slope of the terminal side, and thus the tangent, is positive. So I'm going to leave the answer as positive radical 3. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.